Welcome back again. We are trying to finish our preliminary or prerequisite things that we have in the P. So I think we stopped here, right? We stop here and we say we are going to talk about the polynomial. Generally speaking, polynomial, you saw the general formula, right? You can see from here. We have a general formula like that, and it's called polynomial formula or expression like that. And we know if we have just only nothing, just number without constant, it's called constant. If we have a degree 1, means that we have one variable with the exponent 1, it's called linear, or you can say linear polynomial. For example, you say p of x equal to 2x minus or plus 5. This is the linear equation or linear polynomial or linear whatever you say. We clarify that sometimes you say it's equation, expression, right? Depends on the situation. So generally, if we have that one, it's called linear. If I have x squared, it's called quadratic, is at degree 2, and cubic, and go on. So generally, we have the shape like that, the formula like that. And you can see from here, you can see also from here, we have a term. So only one term, that one's called 2 terms, that one is 3 terms, mid-term, and like that. Later we are going to use, or depending on the formula that we have, we are going to factor them, combine them, depending on the formula that we have. For example, the simplest things between two polynomials is what? Is to add or subtract. For example, you have x to the power 5 minus 2x to the power 4, or 2 plus 3. Add, this is the polynomial expression, plus or add with another polynomial expression like x to the power 4 minus 2x to the power 3 plus 3x to the power 2 plus x. How we add these two expressions? Both of them are polynomial, and it's the simplest one. Why? Because we need to, in our mind or in your paper, you need to organize them, order them. How? For example, I say from the descending, I have x to the power 5, x to the power 4, because we have addition, x to the power 4, now x to the power 3, minus 2x squared plus 3x squared plus x plus 3. Am I right? We just organize them. Maybe that one's simple or easy for some of you, maybe for the others like a beginning. And the important thing is what? We cannot add or subtract between two parts, two polynomials, if they don't have the same degree. For example, in this example, I cannot do anything, just I can add this one. This is x to the power 3, that one x to the power 2, x to the power 2. So my duty or my simplification is between what and what? Just x squared. Understood? You got it? Otherwise, we cannot add them. So we say plus 1, plus 3, minus 2. It will be remain what? X to the power 5, x to the power 4, 2x cubed, plus x squared, plus x plus 3. Am I right, dears? Clear? So the important thing is what? If you have addition or subtraction, the important thing is just compare or just try to simplify those numbers or those coefficients that they are the same, they are on the same degree. How about if I change the previous example to minus? What's going on? For example, we change it to the easier one. If I have another example, x to the power 3 minus 2x to the power 2 minus 1, or number minus 5, minus x to the power 2 x. So what about next step? Could you help me? Yalla. Can you help? They? The first, organize them. Yeah, organize them. The second, multiply minus, right? So minus by minus, minus x squared plus x. Am I right? Now organize them, or you can do it directly. Minus 2x squared minus x squared plus x minus 5. Am I right? Then I remember that. So x cubed minus 3x squared, right? Plus x plus minus 5. You got the idea? Clear, right? Good. So that's about addition and subtraction between two expressions that they are polynomials. So you have a polynomial, 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 subtraction and addition between them. Kindly do that one at home as a homework. Just do it to remember the things that we need. Now, how about multiplication? We know how to multiply. I think we did before. So we multiply number by number and exponent by exponent. Am I right? So how we say 5 by 3 is 15. X to power 3 and x to power 4, the bases are equal. We are going to add or exponent. How about if I have distribution? Means that I have something multiplied outside of the parentheses, brackets. So how we do that? One by one. Am I right? For example, to be easier for you, if I have x multiply x squared plus 5x minus 2, how we do like that? We say is equal to what? 1 by 1. Am I right? Let that one be plus. And that one be minus. Understood? So this is called distribute from left side. I'll get what? X cubed directly, you know why. Minus 5x squared plus 2x. Everything is clear for you? Can you imagine how to do it? Good. Now, how about if I have more things? If I have two parts. Again, for example, the same example, if I have x plus 2 multiply x squared minus 5x plus 2. Easy, the same thing, right? First, then second. Clear, dears? Then later you will arrange them, you will add those exponents that they are there. Yalla, give me the answer of this, or give me the first step. Yalla. All done. You're all right. Thank you. So now it's time to combine between these and that, right? How we do it? X cubed minus 3x squared, okay, minus 8x, no, that one is actually as addition, yeah, so plus 4. Clear, dears? Tamam? You got it? Good. And do that one at home. The same strategy, the same thing, just multiply, you will get the result, and everything is clear for you. Now we have two things. So it's binomial, trinomial, right? Monomial. If I have one, you say monomial. If I have two, I say binomial. If I have three terms, it's called trinomial, and go on. So I think that one is easier for you. Yalla. As a part of the activity, can you do it right now for me? Yalla, do it. Paper, pen. Yes. Now, we are going to the next. Actually, this one is help you, this table, help you to be faster. Maybe you cannot do it directly, maybe you are going to use the indirect way, but that will make you faster in the competition, in the something that you are doing to do it during the exam. The first time you can see all of this binomial. What's a bi? Bi is what? Bi means that 2, right? 2 by try. Binomial is by 2. So we have what? We have a quick multiplication. It's called difference. If you have something like it, it's called difference between two squares. Difference between two squares. You can see. And here's the conjugate product. What do you mean by conjugate product? So that part is called difference between two squares. That one is called conjugate product. Means that we have two things, two parentheses. One of them, A, for example. We have two parentheses, conjugate. We have A, B, one of them addition, one of them subtraction. So it's called conjugate, right? when you multiply them, you don't need to make that 3 steps, then you will get it. For example, if you are using the classical way, I say a square, right, minus ab plus ab minus b square, am I right? Then we will cancel these two and I'll get by a square b square. So directly you can write a square minus b square. Why? Because I have a multiplication between two conjugate. Understood? Good. And how about that one? It's called square of sum, right? Or it's called complete square. If you are going to like that, it's called complete square. First square, 2 first second, then second square. Am I right? How about if I change that one? The Jama'at is just reviewing. You saw that one many times. How about if we change that one to negative, to difference? So what's going on? Just here will be difference, right? The other remains positive. How about opening or sum of cube? You can see cube of sum. The cube of sum is what? You can see a square, a cube, a square, I like that. We have a plus b cube. So I say first, second, first, second, second only. Look, 3, 3. How? I say 3, 2, 1, none. 3, 2, 1, 0 or none, right? So you can control these rules like that. Understood? You don't need to memorize it. If you are using, for example, to solve 3 examples, 4 examples, you will deal with the situation. You don't need to memorize it because later, if you change that on 2 minus, everything will change. Careful. Understood? So please, at least for each line, solve 2 examples. Okay. Do you have any things? Do you have any things about this example? For example, maybe during the limit or anything that you have in the calculus 1, cal 2, you have let me see, x approach to 0, x minus 1, x minus 1 cube. You know, during that time, you need to know how to expand this. How? By this rule. You got it, dear? Later, maybe you will use it. Any question about that? Good. Now, we are going to talk about greatest common factor, GCF. What's the greatest common factor? You know, between the numbers, first of all, we are going to choose the largest number to be out, to be factor. It's called factoring, right? So, you know, what's the common between 24, 40, and 48? It's 8, right? It's 8. So 8 will be out as a factor. Now, you are going to see the smallest degree of the polynomial of which one that you want. For example, I have x and y. So I'm going to talk about x right now. So x to power 4, 5, 3, and 2. Which one is the smallest one? So 2. So I'm going to take out 2. Understood, dear? And how about y? 3, 2, 1. So I'm going to take only y. You get the idea? Then we are going to minus or to decrease each one by the exponent that we took it to out. What do you mean by that? We give you the clue, give you example. For example, I have 2x y squared minus 5, let me 10, now, starting with a number, I'll get what? Am I right? Then it's x time. I'll get what? Huh? y square only, right? 5 x square y to power 6. Why? What did we do?
Factored out.
Exactly. But what did we do before? We do what? We bring it out and x3, right? We say 1 minus 1, 3 minus 1, and we get what? We get 2. You know what I mean? We took one x to out, so means that before we have x to power 1 and x to power 3. Now we subtract minus 1. Why minus 1? Because we took 1 to out. So I got what? 2. So we subtract it, right? Why I say that? Because later if you have a fraction, you cannot imagine. Now is the y time, right? Which one is smallest one? So I'll get what? 1 minus 5 x to power 2 y to power what? Yalla? 4, exactly. What did we do? Minus 2 here, we get 0. Minus 2 here, I'll get what? 6. I think it's not clear. Want another example? Nobody? You want another example?
So we always factor by the smallest power.
Yeah. Then subtract. In your mind, subtract. For example, if I have... Yeah, do that one for me. Wait. Maybe you have another example. No, by group. Let me give you another example. Yalla. Solve that one for me, please. It's clear? 25x cubed minus 5x to power 5y squared minus 10x to power 6y. Yalla, solve. Okay, do it. Y. Now you know we have a trinomial 1, 2, 3, and this one, these three terms, they don't have anything, just 5 is common, and what? X. So I have x to power 3. It remains what? 5x to power nothing, right? And minus x to power 2, you are right, 5 minus 3, 5 minus 3 is 2, then 2x to power 3y. Am I right? Good. Now, if I have 4 terms, look, if I have 4 terms, so how we find the common between them? It's better to organize them together common. How? We make it by group. It's called by group. 2 by 2. I see between these numbers, we have 3 and 12. There's a common, right? And also between x cubed and x squared. So I'm going to write like that. I say is equal to, forget about the other term. I'm going to talk about just these 2 terms together, and this one in another time. I have 3x squared. Am I right? It remains what? X minus 4. Do you have any problem with it? Clear, dears? Jamaat? Good. Now, I'm going to take minus as a common. I'll get what? Minus 2. Careful, minus 4, right? Why? Because minus, multiply minus will give me the plus. Understood here? Good. And you see, there's a common between what? Between these two groups. Am I right? It should be like that. Otherwise, means you need to change your step or make more. So, I'm going to take that one, x minus 4, from right side, left side, up to you. What remains? 3x squared minus 2. Clear? So it's called what? Factor by grouping. You can see factor by grouping. You can bring it to the right side or left side. Does not make a change. Okay, Kaka? Okay, dears? Clear? Any question? So if I have 4 terms, I'm going to think about grouping 2, 2. Understood? Between x and between numbers. Any problem with it? Hello? Question? Good. Now, we have a polynomial. How we factor polynomial? If we have, this is trinomial actually. Yes, mentioned trinomial. And trinomial like that. IC group. Leave me that one for you. Good. So if I have a polynomial, let me start with the smallest one. So factoring of polynomial. First of all, if we have simple one, for example, we have x squared minus 1. How we factor that one? Do you have any idea? Yeah, we say that before, right? We say we make the two part. It's called difference between two squares. X, one of them plus means that conjugate 1, 1. Am I right? If I change that on 2, 4, I'll get what? 2, 2. You are right. 2 by 2. Clear? That's it. Good. Now, if I have trinomial, instead of binomial, if I have trinomial, 3 things like that. Like this example, look. X squared minus 6x minus 16. So, x squared minus 6x minus 16. All right? So how we factor this one? Yalla. You have something that can help you for all of the examples. It's called what? Do you have any idea about it? Like what?
X minus 3.
Yeah, exactly. Yes. So we have, as he mentioned, we will make it two parentheses. Okay, we will make a 3 terms trinomial to 2 parentheses. We distribute x squared, one for the other for the first and the second for the second, right? Any question? No. Good. Now we are going to multiply the sign. The sign of in front of x is what? It's positive, right? Positive multiply negative, negative. Negative multiply negative, positive. Shall I repeat that one? Clear? Now, we are going to factor 16. We are going to factor, just let me, minus, good. Factor 16 to such numbers. Yalla. How many numbers will give me the 16? Maybe 1 by 16, am I right? Maybe what? 2 by 8, you are right. Maybe 4 by 4, you are right. What else? Nothing else, right? So which couple of numbers I should select and why? 2 and 8. 2 and 8. Why? Because the addition or subtraction between these two numbers should be 6, should be the second or the coefficient of the x, or you can say midterm, right? So I'm asking myself, 1 plus 16 is equal to what? 17. 1 minus 15, so it's not my option, right? How about between 2 and 8? If I add, I'll get what? 10. If I subtract, I'll get what? 6. So that's what I need, right? So it's 2 and 8. You got it? Yes, I know. You got it for third one, yalla. Yeah, now is the sign is very important. The third things. We have minus 6. So if I put minus 2 here, I'll get what? I'll get minus 2x plus 8x, right? I'll get what? Plus 6, which is not correct. I should change what? I should sweep the numbers to what? To 8 to 2. Now you got it. So if you have x squared minus 6x minus 16, and you try to factor this trinomial, I'm going to use positive, negative, negative, positive. Then the important thing is to get what? To get the second term, midterm. How? By multiplying these two numbers, the closest to each other, right? And the farthest to each other, like, and I'll get minus 6x. So means that correct. You got it? This is it's called how to unfolding, or whatever they call. Each book has got special name, but the important thing is what? To check yourself you did well or not. Do not forget about to factor that one. Do not forget about minus 6. Clear, dears? So I'm going to leave that one for you. There's something need a little bit work. Homework. Do it at home, please, okay? Or at least ask your teachers in the tutorial, in the recitation. Understood? Good. The same, that one also depends on the AC grouping. Do that. Clear? Good. Now we have perfect square, or in some books written by complete square or perfect square. The same. What's a perfect square? Can I call that one as a perfect square? It's perfect square? No. Why? Because perfect square, yes, is what? Is to change the trinomial to binomial, to one parenthesis. How? Like that. So, if I expand that one, I'll get what? Yalla jamaat. Expand ikam. Okay? First square plus 2ab, right? Plus b square. That's called perfect square. Example. Here's the many examples. We have what? 4 x squared, okay, 20x plus 25. So give me the square. 2x plus 5. 2x plus 5 times square, right? Good. So 4x, 2 by 2, 4, 4 by 5, 20. Then 25 is right. Did you get the idea, Jamaat? Kaka? You got it? Shall I repeat it? Question? Like? You like it? Okay, good. So, how many types do you have? 2 types of the perfect square. One of them is addition here. One of them subtraction. How we change that one? Here's the combination of them. So, this is called perfect square and trinomials. We change it to what? To one parenthesis square. Example. What example? Do you need more example? Any needs? Jamaat? No question? No comment? No like? Are you here? Good. So we can, for example, if I have x minus 2, I say x squared minus 4x plus 4, right? This is called expanding, that one's called factoring. Expand, factor. But all of them is what is complete perfect square. Good. Now, we are going to talk about something else, special form. What's a special form? For example, we have difference between two squares. How? You can see from here. I'll get what? 16 x squared minus 49. How we deal with that situation? It's easy, right? I have two squares, a squared, difference b squares. So I'll get what? I'll get, for example, x squared minus 4, I say is equal to what? X plus 2. Am I right? Any question? Okay. Kindly solve that one for me. Yalla. Paper and pen. Look again. That one is easy. There's difference between two squares. So I have 2x minus plus 5, right? And that one is sum between two squares. So we don't have anything here. Careful. That's why I gave you that example. We don't have an addition between them. So if I have a square, we have what? One rule is what? Difference. Kindly write this note, okay? You need them. So be careful. We have such case like that. Yeah. No, just leave it. For example, if you have anywhere that one, leave it. Do not change. Do not make any parenthesis. But you can see from here, we have what? Between two cubes, we have what? Addition and subtraction. So what did we don't have? We don't have that one, right? We don't have it. Understood? But for cube, yes, we have a sum. We have also a subtraction, or you can say difference or sum. So how we deal with that one? We make it two parentheses. One of them big, one of them small. If here you have addition, here will be changed to the negative. If you have a subtraction will change to the summation. Let me give you an example. For example, we say x to power 3 minus 8. In my mind, 8 is what? 8 is 2 cube, right? So now I have what? Difference between what? Two cubes, right? So I say is equal to one small, one large, one binomial, one trinomial. So root of here, cube root of here, understood? 2. You got it, dears? Then here's square, change the sign, first multiply second. We don't say 2 multiply, no, here's just 1. First, plus, usually plus, second square. Understood, dear? Let me change that onto another example. X to power. Let me change it to another things. 125 minus x to power 3. Yalla. Let me plus. They. Let me sweep it. Wait. This example is easy. Yalla جماعة. Small, large. Cubic root of first, I have plus 5, right? Okay, so first square minus, am I right? Minus, okay. First multiply second, usually plus 25, second square. So you can see the rules here. And at home you can deal with the situation. Any question, dears? Any question, anything? Good. Okay. Now we have rational expression. What's a rational expression? We have expression first. We have polynomial over polynomial. So you can see from here, from this example, this is trinomial. That one is what? Binomial. So we have a polynomial over polynomial. How about the second? The same. Am I right? Hello? Good. So it's called what? Called rational, right? Rational expression. Okay. We got rational. What's rational? Now the important things in rational is what? Is to exclude those numbers that make denominator to be 0. Or maybe you have multiplication between two rational, maybe addition, and that's it. So how we do it? One by one. First, we're going to talk about domain. What's the domain? Domain is something that you can give to the function. For example, we say the domain of here is 20 students. The capacity of here is 20 students. If the 20 first come, there is no way. Okay? You have a tomato factory. You have a tomato paste. What's the input? Tomato and can, right? If you give the cucumber, it's not acceptable, right? So that's the domain. Domain is something that I can put in the function. For example, it's like a factory, as we see. It's a function. Input is domain. I'm not going to talk about output right now. Later, maybe in chapter 1 function, we are going to talk about the range there. But just input. What's input? Input is something that we can give to the function. Like we say, tomato and can will give you tomato paste. Right? That's easy. Good. So, if I have rational expression, like for example, rational function, or later you can recall as a function, I have x squared minus 5x plus 2 over x minus 1. When we say function, and I'm going to look at the function, I see it's a rational, right? Why is it rational? Because I have a polynomial over polynomial. Clear that, right? Good. So try to exclude those numbers that make a denominator to be 0. Which number? So I say directly, in my mind, let x minus 1 be 0. So x will be 1, right? So I say the domain is x not be 1. You got it? This is the simplest one. Did you get that example, dears? So when I say the domain of the rational, you know it's equal to what? It's equal to those numbers that not make a denominator to 0. So how about this example? Tell me. Yalla. 5. X not be 5. So how do you express that x not be 1, x not be 5? We say 1 to infinity union 1 to infinity. Am I right? What do we mean? Is that if I have a real number, just exclude 1. How about for that example? Just exclude 5. Am I right? Am I right, dears? 5 to the minus, 5 to plus. Just exclude only single number. What's a single number? 5. How about the second one? Plus minus 3. You're right. So we have two numbers, couple of numbers, because x squared. So I have two numbers should be removed. It's plus minus. So how we deal with it? How we express on the real line? How we show? How we present? We say 3, right? 3 to infinity. Between 3 and minus 3. Am I right? From minus 3 to minus infinity. You got it? Yes.
Minus 3 is something to put it back into the function because sometimes 0 gets 0.
Yes. So
Like we have to account every time that we get a plus minus number, we should put it back to the function because not all the time we can have a correct measure.
yeah, exactly. So in this one, that maybe you mix with something else. You mean the vertical asymptote, I think. Yeah, that's why. So here just domain. Okay, I agree with you. But for next chapter, okay, you are right. When you got something, you should check it in the function to be sure that it's a vertical asymptote or not. Right? Good. So keep it later. We will make a notification there. Any question about the domain here? Just only make the domain denominator to not be 0. How about if I have, for example, such example like that? Yalla. Give me the domain of this rational expression.
X plus 2 or minus 2.
So, we are going to do our strategy. Make a factor, right? So I have what? X minus 8, x plus 2. Do you remember that example? So you see the domain is what? Is everything not to be what? Minus 2 and 8. So, what do you mean by this real line? We can, yes, expressed as union, sorry. Okay. The domain is what? Minus infinity to minus 2, union minus to 8, right? Union 8 to infinite, right? You can see. Any questions? Did you understand, dears? Okay.